everyone, welcome to our channel Knowledge of Friends. सब्सक्राइब टू our channel and click the bell icon for the latest update. आज हम डेटा वेयर हाउसिंग की क्लास करने वाले हैं, जो कि डेटा वेयर हाउस एंड डेटा माइनिंग आपका सब्जेक्ट का नाम है, एंड जो कि क्लास आपकी थर्ड है. ऑलरेडी हमने क्लास 2 कर लिया है, एंड जिसमें हमने यूनिट 1 जो है वो हम ऑलरेडी कंप्लीट कर चुके हैं, जो कि डेटा वेयर हाउस से आपका यूनिट का नाम है. आज की क्लास में जो हम स्टार्ट करेंगे वो यूनिट 2 से स्टार्ट करेंगे, जो कि डेटा वेयर हाउस प्रोसेस एंड टेक्नोलॉजी. This is the name of the unit that what we have to cover up here. This is the third class. First of all, it's a huge request from my side to all the viewers. Please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the data warehouse process and technology, what we have to understood about the warehousing strategies. In the warehousing strategies, it is defined as a part of the information technology strategies of the enterprises here. Talking about the components of warehousing strategies, there are the three components that will discussed in a detail. That is your primary data warehouse rollout plan and primary data warehouse architecture, and as well as that is your shortlisted data warehouse environments and tool. Then after that we'll discuss about warehouse management and support process, which is they are the designed to address the aspects of the planning and managing in a data warehouses projects that are critical to the successful implementation and subsequent extensions of the data warehouse. That's what we have to discuss here. Next is your time horizons that we'll discuss in this class. In the time horizon, that as a rule there are the two time horizon, the capacity planner and a 5-year plan time horizon as well. Then we'll discuss about workload matrix, that in a matrix that is created as intersections of the tables in the data warehouse and the processes that will run in the data warehouse as well. Talking about the another one we'll discuss, that is your warehouse planning. In that it details the preliminary scope of one warehouse rollout by obtaining the detailed user requirement for the queries and reports, creating of the preliminary warehouses schema that is designed to meet the user, and that is in the terms of it. And then after that we will have to discuss moreover about the data warehouses implementation, where it describes the activities related to the implementing that one rollout of the data warehouse as well. And then we have to discuss about the extraction subsystem, which is the term extraction refers to the process of retrieving the required data from that operational system tables as well. Then we'll discuss the transformation subsystem, and which is also that it is literally a transform that data to accordance with the business rules and standards that have been established for the data warehouse. Before starting with in a detail all these topics, I will just tell you, if they had asked you about medium type questions, so you have to just approximately 250 words in about, and if it is long answer then you have to answer near about 400 words here. Then only you are able to get the marks as well, because the students were confused that how long we have to write an answer. So that is the probability has been mentioned. Now we'll go ahead with a detailed in it all these here. That is the first question has been asked. Explain some elements of warehouse strategies. Some elements of warehouse strategy. Some elements of warehouse strategies that what we have to discuss here. In this, that at a minimum the data warehouse strategy should include the following elements, and that elements that we'll discuss in a detail. So here the first element we have, and that is the preliminary data warehouse rollout plan. Preliminary data warehouse rollout plan. So in this, that not all the user requirements that can be met in one data warehouse project, such a project would necessarily be large and dangerously unmanageable. It is more realistic to prioritize the different user requirement and assign them to a different warehouse rollouts and doing so that allows the enterprises to divide the warehouse development into the phased successive rollouts, and where each rollout focuses on meeting an agreed set of requirements. The iterative nature of such an approach allows the warehousing temp and to extend the functionality of the warehouse in the manageable manner as well. The second we have here is your preliminary data warehouse architecture. So here for the primary, that is your primary data warehouse architecture. In this, that defines the overall data warehouse architecture for the pilot and a subsequent warehouse rollout to ensure the scalability of the warehouse, and whenever possible defines the initial technical architecture of each rollout here. The third we have here is your, that is your shortlisted data warehouse environment and tools. Shortlisted data warehouse and environment and tools. So shortlisted data warehouse environments and tool here, that there are number of tools and warehousing environment from which is to be chosen, and create a short list for the tools and environment that appears to meet warehousing needs, and a standard set of rules will lessen tools integration problem and will minimize the learning required for both warehousing team and warehouse user as well. So now we'll go ahead with the detail here, that is we have to discuss some interviewing tips in brief, and that is very important, even though that has been asked in your this subject as well. The another one we have some interviewing tips in brief that we'll discuss. Okay, so some interviewing tips in a brief that what we have to discuss here, and that is the first is that to avoid making commitment about warehouse scope, because we have to avoid making, because बहुत सारे ऐसे बच्चे होते हैं कि like they are in interview, they are just making the that the commitment about the warehouse scope, but they are not able to fulfill that, and then after that it will be give you a negative impact. So the first we have is you avoid making commitment about warehouse scope. So here avoid making commitment about the warehouse scope here. It means it will not be surprising to find that some of the queries in the report requested by the interviewees, and that cannot be supported and by the data that currently reside into the operational databases. So the interviewers that should keep this in mind, that that they communicate this potential limitations to the interviewees, and that the interviewers cannot afford to make the commitment regarding the warehouse scope at this time. So after that, other than that, if I'm talking about the another one is just keep the interview objective in mind. Second is keep the interview objective in mind. You have to keep the interview objective कि किस वजह से इंटरव्यू हो रहा है, किस पोस्ट के लिए हो रहा है. You have to keep that objective in the mind, and that the objective of these interviews is to create an inventory of requirement, and this is no need to get a detailed understanding of the requirement at this point. The third we have here is your do not overwhelm the interviewees. Do not overwhelm the interviewees. So do not overwhelm the interviewees means that the interviewing team should be small and two people are the ideal number, one to ask question and another to take notes, and interviewers may be intimidated if a large group of interviewers is shown up as well. The third one we have here, the fourth one we have here, that is the reward the session if the interviewees lets you. That is the fourth one. Record the session if the interviewee lets you. So in this, that most interviewers will not mind if the interviewers bring along a tape recorder to record the session. The transcript of the session may later prove helpful as well. The next we have is that change the interviewing style depending on the interviewee. Change the interviewing style depending on the interviewee. So here that the middle manager is more likely to deal with the actual report and a detailed information requirement, and senior executives are more likely to dwell on strategic information needs. Change the interviewing that style as well, and change the interviewing style as needed by adapting the type of the question to the type of the interview as well. The next we have is your listen carefully. In here, that is your listen carefully if I'm talking about here, and that is here, and that listen to what the interviewee has to say, that the sample interview questions are merely a starting point and follow-up questions have the potentials of yielding the interesting and critical of yielding interesting and critical information. And with that, take note of the terms as the interviewee that uses and popular business terms such as your profit that may hear a different meaning and connections within the enterprises as well. Now we'll go ahead with the another one, that is to obtain the copies of reports whenever possible. Obtain copies of reports whenever possible. Obtain copies of that report whenever possible. That means that the report will give the warehouse team valuable information about the source system which the system produce the report, and as well as the business rules and terms as well. And if the person manually makes the report, the team may benefit from talking to this persons as well. So this is comes under obtain the copies of reports whenever possible as well. Now we'll go ahead with the movement, and that what we have to discuss here. So now we'll go ahead to discuss about define the warehouse management and support process and explain some issues that are arises during the courses of a project as well. So here we'll discuss about the warehouse management. Warehouse management support process as well. So warehouse management and support process. Warehouse management and a support process are designed to address aspects of planning and managing a data warehouse project that are critical to the successful implementations and subsequent extensions of the data warehouse, where that unfortunately these aspects are of all other too often overlooked in the initial warehousing deployment as well, where these processes are defined to assist the project manager and a warehouse driver during the warehouse development project, and some issues that arises during the course of the projects are, so that we'll discuss about the issues here. In the issue that arises during the courses of the project, that the first we have, the first issue has been founded out, that is urgency. In the urgency here, indicate the priority level of the issues, that is high, medium or low level, high, medium or low, and low priority issues that are left unresolved may later become a high priority, and the team maybe has agreed on the resolution rate depending on the urgency of the issue as well. For example, the team can agree to resolve the high priority issue within 3 days, medium priority issues within a week, and low priority issues within a 2 week. That has been the durations here, the urgency here. If it is a high priority issue, then you have to solve within the 3 days, and if it is a medium priority, then you have to solve within a week, and if it is a low priority, then of course you can solve that issue in within 2 weeks as well. Now we'll talk about the second one, that is your raised by. In the raised by here, that to identify the person who raised the issue, if the team is large or does not meet on a regular basis, provide information on how to contact the person. Example, that is your telephone number, email addresses. The people who are resolving the issue may require additional information or details that only issue the originator that can can provide. And the third we have here is your assigned to. In the assigned to, that is to identify the persons on the team who is responsible for resolving the issue. Note that this person does not necessarily have answer, however he or she is responsible for tracking down the person who can actually resolve the issue, and he or she also follow up on the issue that has been left unresolved as well. The next we have is your data opened. In the data opened here, this is the date date opened. So date opened, that this is the date when the issue was first lodged here. So that is your date opened. The fifth we have here is your date close. In the date close, this is the date when the issue was finally resolved here. Then the sixth is your resolved by. In the resolved by here, that the person who resolves the issues must have the required authority within the organization, and user representatives typically resolve the business issue, and the CIO or a designated representative typically resolve the technical issue, and the project sponsors typically resolve issues related to the project scope as well. Now we'll go ahead to discuss about the resolution description. In the resolution description here, that states briefly the resolutions of the issue and 2 or 3 sentences that provide a more detailed descriptions of the resolution in a separate paragraph. If subsequent actions are required to implement the resolution, they should be stated clearly, and the resources that should be assigned to implement them. Identify the target dates for the implementation as well. Now we'll go ahead to discuss about what do you understand by the horizons. In the terms of the horizons here, that what do you understand by the horizons, that is your time horizons. In the time horizons here, that as a rule there are the two time horizon, the capacity planner that should aim for a 1 year time horizon and a 5 year time horizon, and that the 1 year time horizon is important in that it is on the immediate requirement list for the designer. In the other words, at the rate that the data warehouse that becomes designed and populated, and that the decision made about resources for a 1 year time horizon will have to be lived with, and the hardware and the possibly software acquisition will have to be made, and a certain amount of burnt in that is will have to be tolerated as well. A learning curve for all the parties will have to be survived, and all one of the 1 year horizon, the 5 year horizon is of importance as well, and it is where that the massive volume of the data will shown up, and it is where that the maturity of the data warehouse will occur as well. So with this, that is the projecting the hardware requirements out of year 1 till year 5. So that has been presenting in the form, graph is going from down to up. This is for year 1, and this is then again year 2, year 3, year 4, and year 5. And this is all about, and this is for year 5 here, and these were so this is all represented in the terms of it. Now this is projecting the hardware requirements out of year 1 till year 7 here, year 5 here. And as increasing interesting question is that why not look at the 10 years horizon as well. Certainly the projection that can be made of the 10-year horizon, that however those projects are not made usually, because these are the approximately from year 1 to year 5 has been made. So it is very difficult to predict what the world that will look like in the 10 year from now. So it is assumed that the organization will have much more experience in handling the data warehouse 5 years in future, so that the design and the data management will not pose the same problem they do in the early days of the warehouse. And it is assumed that there will be a technological advances that will change the considerations of building and managing a data warehouse environment as well. Now we'll go ahead to discuss about what do you mean by the term calculating disk storage. So what do you mean by that calculating a disk storage here? That the calculation for the space are almost always done exclusively here. Here in the calculating disk storage, the calculation, as I told you, the calculation for the space are almost always done exclusively for a current detail, the data in the data warehouse. The reason why the other levels of the data are not included in this analysis is that they consume much less storage than the current detail level of the data, and they are much harder to identify as well. There, the considerations of capacity planning for the disk storage center around the current detailed level, and the calculation for the disk storage are very straightforward. That the elements of the calculations, the tables are given, and the rows in the tables as well. That is disk storage, and of course the key attributes as well. That is eliminating the disk storage requirement for the data warehouse as well. Going ahead, that to calculate a disk storage, first the tables that will be in the current detailed level of the data warehouse are identified. Admittedly, when looking at the data warehousing from the standpoint of planning, where the little or no detailed design has been done, it is difficult to devise what the tables will be, and in the truth only the very largest tables that need to be identified as well. and usually there are finite numbers of those tables in even in the most complex of environments as well. Going ahead here, that the once the tables are identified, the next calculation is how many rows will there be in each table. And of course the answer to the questions depends directly on the granularity of the data found in the data warehouse. The lower the level of the detail, the more the number of the rows, and in some cases of the number of rows that can be calculated quite accurately. Where there is a historical records to rely upon, this number is calculated. For example, where the data warehouse will contain the number of phone calls made by a phone company's customers, and where the business is not changing dramatically, this calculation can be made. But in the other cases, it is not so easy to estimate the number of occurrence of a data as well. Going ahead with the detail, we are explain the processor requirement in detail. And the processor requirements. The processor requirements we have to talk about in a detail here. That is, in order to make sense of the estimation of the processor requirement for the data warehouse, the work passing through the data warehouse processor must be divided into one of three category: background processing, predictable, that DSS processing, or unpredictable processing as well. So we will talk about the unpredictable DSS, which is predictable DSS, and as well as the data warehouse processor, which having a background processing as well. That comes under the three types of processing that occurs in the data warehouse, and where we have a client as well, which has been bidirectional as well. The background processing is that the processing that is done on a predictable, usually a batch basis. Typically of a background processing is extract processing, and the data warehouse loads monitor, so that sorts, merges, restructuring, and that restricting the index creation, etc. Where the background processing is that utilitarian processing necessary to the data warehouse, but not directly associated with a query or an analysis of the data warehouse data. Where the background processing that can be run at off-peak times, and that can be spread evenly throughout the day, and this is the seldom much of the time constant for the background processing as well. For the predictable DSS, that processing is that the processing is that regularly done, and usually on the query or truncation, that is transactions basis. That a predictable DSS processing may be modeled after DSS processing and done and today, but not in the data warehouse that environment. Or predictable DSS processing may be projected as well as are other parts of the data warehouse workload. The parameters of the internet of the data warehouse designers are: the first is the number of the times the process will run, the number of input outputs the process will use, and where there is an arrival peak to the processing as well, and the expected response time as well. That comes under in it with reference towards the processor requirement. Let's go ahead with another one, and that what we have to discuss is to write a short note on a workload matrix. In a workload matrix here, the workload matrix is a matrix that is created as the intersections of the table in the data warehouse and the processes, the background and the predictable DSS processes, that what we have to discuss here, and that will run in the data warehouses, and a matrix that formed by a table and a processes as well, that is the processor on that is your x-axis, and the y-axis on the tables that has been represented till 1 to n as well. And where a matrix approach helps to organize the activities, where in the same case that the workload matrix is then filled in, and the first passes of the workload matrix is then filled, and the first passes by the filling in the matrices involve putting the number of the calls and resulting input output from the calls, and the processors would do if the processes were executed exactly once during the 8-hour window, and that shows a simple form of a matrix that can be filled in for the first step as well. Now this is the number of calls, input output per access, and the simplest form of matrix is to provide that individual transaction in the terms of calls and input output as well. Now we'll go ahead to discuss about it. That is, what do you mean by a backup and a recovery strategies? Backup and recovery strategy here, that is, following factors as considered with defining a backup and a recovery strategies. First we have is the data to be backed up. So data to be backed up, identify that the data that must be backed up on the regular basis, and this gives an that is indications of the regular backup size, where aside from warehouse data and metadata, the team might also want to back up the contents of the staging or deduplication areas of the warehouse as well. The second, we have your batch window of the warehouse. The batch window of the warehouse, that is, the batched backup mechanisms are now available to support the backup of the data even when the system is online, although these are expensive, and if the warehouse does not need to be online 24 hours a day and 7 days a week, then determine the maximum allowable downtime for the warehouse, that is, determine the batch window as well, and where part of the batch window is allocated to the regular warehouse that load and possibly to report the generations and the other similar batch jobs as well, to determine the maximum time period that is available for the regular backup and a backup verification as well. Talking about the next one, that what we have to discuss here, that is your maximum acceptable time for recovery. Maximum acceptable time for recovery in the case of the disaster that results in the less loss of warehouses data and the backups that will be to restored in the quickest way possible. Then the different backup mechanism amplify the different times frames for the recovery, determine the maximum acceptable length of the time and for the warehouse data and the metadata that to be restored qualify, that is the quality assured and brought online as well. The another we have is your acceptable cost for backup and recovery. Acceptable cost for a backup recovery here, that a different backup mechanism imply the different costs, and the enterprises may have budgetary constraint that limits its backup and recovery options, and also consider the following when selecting the backup mechanism as well, that is your archive format. In the archive format, that the use of the standard archiving format to eliminate the potential recovery problem as well. The second we have is your automatic backup device. In the automatic backup devices here, that without these the backup media, that is example the tapes, will have to be changed by hand each time the warehouse is backed up. The next we have is your, that is, parallel data streams. In parallel data stream, that a commercially available backup and a recovery system that now support the backup and recovery in the database, and though the parallel streams of the data into from multiple movable storage devices. This technology is especially helpful for the large database typically found in the data warehouse implementation. The next we have is your incremental backups. In incremental backups, that some backups are recovery system and also supports the incremental backups to reduce the time required to backup daily. Incremental backups achieve only new and updated data as well. The next we have is your that is offsite backup. The offsite backups here, that remember to maintain the offsite backups to prevent the loss of the data due to the site disasters such as fires here. The another we have here backup and recovery procedure. The backup and recovery procedures that formally define and document the backup and recovery procedures that perform recovery practice to ensure that the procedures are clearly understood here. Now we'll talk about the another one, that is what is data warehouse planning, and explain its activities. Now we'll discuss about that is your data warehouse planning. The question arises that what is data warehouse planning and its activities as well. So we'll go ahead to discuss in a detail. The first we have to know about data warehouse planning. The data warehouse planning details the preliminary scope of one warehouse rollout by obtaining a detailed user requirement for the queries and reports, creating a preliminary warehouse schema designed to meet the user requirement, and mapping source system that feeds to the warehouse schema field as well. The team gains a thorough understanding of the efforts required to implement. Where same case, a planning projects typically last between 5 to 8 weeks. Depending on the scope of the rollout, the progress of the team varies depending, among other things, on the participations of enterprises, resource person, the availability and the quality of the source system, documentation, and the rate at which issues are resolved. In the parallel, during data warehousing planning, there are the two activities. There are two activities. The first activity we have, that is conduct decisional requirement analysis. In conduct decisional requirement analysis here, the object of decisional requirement analysis is to gain a thorough understanding of the information needs of decision makers, and from top down user requirement has gone, and the working of the decisional requirement analysis is working of top down decisional requirements analysis, which represent the top down aspects of data warehousing, where in the same case, if I'm talking about in a detail, that the use of the warehouse strategies results as the starting point of the decisional requirement analysis and preliminary analysis that should have been conducted as part of the warehouse strategies formulations, and review the intended scope of the warehouse rollout as documented in the warehouse strategies document, finalize this scope or by further detailing the preliminary decision requirement analysis as well. It will be necessary to revisit the user representatives, and the rollout scope is typically expressed in the terms of the queries or reports that are to be supported by the warehouse by the end of the rollout as well. In the same case, that the project sponsor must review and approve the scope to ensure that the management expectations are set properly here. Now I'll go ahead to discuss about the conducting warehouse planning without a warehouse strategies here. conducting warehouse planning without a warehouse strategies. So here in this, it is not unusual for the enterprises to go directly into the warehouse planning without previously formulating a warehouse strategies. This typically happens when a group of users is clearly driving the warehouse initiative and are more ready to participate in an initial rollout as underrepresented. In this type of a situation, a number of tasks from the strategy formulation will have to be conducted as a part of the planning for the first warehouse rollout, and these attacks are as follows. That is, first we have here that to determine organizational extent. Determine organizational context here, that an understanding of the organization is always helpful in any warehousing project, especially since organizational issue may completely derail the warehouse initiatives. The second is to define the data warehouse rollout. Define data warehouse rollouts. Here, that is, although the business users may have already predefined the scope of the first rollout, it helps the warehouse architect to know what lies ahead in a subsequent rollout as well. The next we have in this, that is define data warehouse architecture. In this, that define the data warehouse architecture for the current rollout, and if possible for subsequent rollout as well, and that is for the architecture in terms of it. The another we have is evaluate development and production environment and tools. Evaluate development and production environment and tools. In this, the strategy formulation was expected to produce a short list of the tools and computing environment for the warehouse, and this evaluation will be finalized during a planning by an actual selections of both environments and tool here. The another and the last we have is here, that is to conduct decisional source system audit. In this, that the decisional source system audit is a survey of all information systems that are current or potential source of data for the data warehouse, and a primary source system audit during the warehouse strategies formulation should provide complete inventory of the data sources, identify all possible source system for the warehouse if the information is currently unavailable here as well. Let's go ahead with another one. That the another question is, list down the various factors when creating the implementation plan, where we have to discuss about the factors when creating the implementation plan. Factors when creating the implementation plan. And with respect to that, here the first we have the number of source systems and their related extraction mechanism and logistics. Number of source systems and their related extraction mechanism and logistics here. So in this, that the more source system there are and the more complex extractions and the integration process will be. The second is the another one, that is your number of decisional business process supported. Number of decisional business processes supported. Here, the larger the number of the decisional business processes that supported by the rollout, the more users are there who will want to have say about that the data warehouse content and the definitions of the terms and the business rules that must be respected here. Another one we have your number of subject area involved. Number of subject areas involved. In this is a strong indicator of the rollout size, and the more subject area there are, the more fact table will be required, and this implies more warehouse field to map to the source systems, and of course the larger rollout scope as well. The another we have here is your, that is estimated database size. In the estimated database size, the estimated warehouse size provides an early indications of loading, indexing, and capacity challenging of the warehousing effort. The database sizes allows the team to estimate the length of the time it takes and to load the warehouse regularly, given the number of the records and the average length of the time it takes to load and index each record as well. The another we have is your availability and quality of the source system documentation. Availability and quality of source system availability and quality of a source system documentation. Here, that is if I'm talking about a lot of teams time that will be waste and on searching for and understanding the data that are available in the source system, and the availability of a good quality documentation will significantly improve the productivity of the source system auditors and a technical analysis as well. Talking about the next one we have here, that is data quality issues and their impact on the schedule. Here, unfortunately, there is no direct way to estimate the impact of the data quality problem on the project schedule. Any attempts to estimate the delays often produce unrealistically low figures, much to concentration of warehouse project managers as well. The next we have here is your required warehouse load rate. Required warehouse load rate here, that a number of factors external to the warehousing team, that is particularly the batch windows of the operational system and the average size of each warehouse load, that will affect the design and approach used by the warehouse implementation team as well. Let's go ahead to another one, that is your required warehouse availability. the required warehouse availability, the warehouse itself will also have batch window, and the maximum allowed that downtime for the warehouse also influences the design and approach of the warehousing team. A fully available warehouse that is 24 hours into 7 days that requires an architecture that is completely different from that required by a warehouse that is available only 12 hours a day and 5 days a week as well. Here with the next one we have your lead time for a delivery and a setup of selected tools, development and production environment. And production environment. Where that is the project schedules sometimes fail to consider the length of the time required to set up the development and production environment of the warehousing project, and while some warehouses implementations task can proceed while the computing environment and tools are on their way, significant progress and that cannot be made until the correct environment and the tools sets are variable here. The another we have here is your time frame required for IT infrastructure upgrade. Here in the time frame required for IT infrastructure upgrade, here that some IT infrastructure upgrade, example the network upgrade and or extension that may be required or assumed by the warehousing project, and these dependencies should be marked on the project schedule, and the warehouse project manager must coordinate with the infrastructure project manager to ensure that a sufficient communication exists between all concerned teams as well. Now we'll discuss about another question, and that is what is data warehouse implementation and what were the key consideration that are taken when the finalized physical warehouse schemes are used schemas are used here. So we'll go ahead further, and that what we have to discuss even though, and that is as follows. Data warehouse implementation. In data warehouse implementation, the data warehouse implementation approach presented and described the activities that is related to implementing one rollout of the data warehouse, and the data warehouse implementation team builds or extends an existing warehouse schemas that is based on the final logical schema design that is produced during the planning, and the team that also builds the warehouse subsystem that ensures a steady regular flow of clean data from the operational systems into the data warehouse. The other team members installs and configure the selected front-end tools to provide the user with access to the warehouse's data as well. And implementation projects that should be scoped to the last between 3 to 6 months, and the progress of the team that varies depending among other things like on the quality of a warehouse design, the quality of the implementation plan, and the availability and participation of enterprises resources, that the resources, persons, and the rate at which the project issues are resolved. The key considerations we have here, the first we have is just schema design. In the schema design here that finalize the physical design of the fact and the dimensions tables and their respective fields, and the warehouse database in administrator, this is DBA, that may opt to divide one logical dimension, example customer, into two or more separate one, that is example a customer dimensions and a customer demographic dimensions as well, to save a space and improve the query performances as well. The second we have is your indexes. In the indexes here, that is that identify an appropriate indexing method to use on the warehouse tables and fields, that is based on the expected data volume and the anticipated nature of the warehouse queries. Verify initial assumptions that made about the space required by the indices to ensure that the sufficient space has been allocated as well. The third we have your partitioning. In the partitioning here, that the warehouse DBA that may opt to partitions fact and the dimension table, that is depending on their sizes and on the partitioning feature that are supported by the database engine, and the warehouse DBA that who decides to implement the partitioned view must be considered the trade-off between the degradations in a query performances and improvement in a warehouse manageability and a space requirement as well. Let's go ahead with another one, and that what we have to discuss about it. We'll have to go ahead with write a short note on extraction subsystem and also discuss the transformation subsystem as well. Let's go ahead here. So here we'll go ahead to discuss about the extraction subsystem. The extraction subsystem here, that the first among the many subsystems on the back end of the warehouse is the data extraction subsystem, and the term extractions refers to the process of retrieving the required data from the operational system tables, which may be the actual tables or a simply copy that have been loaded into a warehouse server. An actual extraction that can be achieved through a wide variety of mechanisms, ranging from the sophisticated third party that talks to the custom written extraction scripts or programs that are developed by in-house IT staff. Third party extraction tools are typically able to connect to mainframe mid-range and that is Unix environment, thus freeing their users from the nightmare of the handling heterogeneous data sources. And these tools also allow users to document the extraction process, that is they have a provision for storing the metadata about the extractions as well. And these tools unfortunately are expensive. For this reason, organization may also turn to writing their own extractions program, and this is a particularly visible alternative if the source systems are on on a uniform or a homogeneous computing environment. Example, all data resides on the same RDBMS and they make use of the same operating system. The custom written extraction program, however, may be difficult to maintain, especially if these programs are not well documented, and considering how quickly business requirements will change in the warehousing environment, and ease of maintenance is an important factor to consider. The first that I will discuss about transformation subsystem. Transformation subsystem. In the transformation subsystem here, that the transformation subsystem literally transforms the data in accordance with the business rules and standards that have been established for the data warehouse. And the several types of transformation are typically implemented sources in the data warehouse. We have the first one is your format changes. In the here, that is the format changes, each of the data fields in the operational system that may store data in a different format and a data type. These individual data items are modified during the transformation process to respect a standard set of formats, and that is, for example, all the data formats that may be changed to respect a standard format or a standard data type is used for the character fields such as name and address. The another one we have here is deduplication. In the same of deduplication here, that records from the multiple sources are compared to identify duplicate record based on matching field values. Duplicate are merged to create a single record of a customer, a product, an employee, or the transaction. The potential duplication are the logged as exceptional that are manually resolved, and that duplicate the records with the conflicting data. That values are also logged for manual correction if there is no system of record to provide the master or a correct value as well. The third we have is just splitting up of fields. Splitting up fields. In this splitting up fields, if I'm talking about data item in the source system that may need to be split up into one or more fields in the warehouse, and one of the most commonly encountered problems of the nature that deals with the customer addresses that have simply been stored as several lines of text, and these textual values may be split up into the distinct field, and that is your street number, street name, building name, city, mail, or a zip code, a country, etc. The another one we have is your integrating fields. In the integrating fields here, that the opposite of splitting up fields is integration, and two or more fields in the operational system that may be integrated populate one warehouse as well. The another one we have your replacement of values. In the replacement of values that are used in operational system that may not be comprehensible to a warehouse users. For example, the system code that have a specific meaning in operational systems are meaningless to decision makers, and the transformation subsystem replaces the original with new values that have a business meaning to a warehouse user as well. The another we have your derived values. In the derived values here, that is the balances, that ratio, and the other derived values that can be computed using an aggregate formula by pre-computing and loading these values into the warehouse. The possibility of the miscomputations by individual user is reduced, and a typical example of a pre-computed value is the average daily balances of the bank account, and this figure computed using the base data and is loaded as into the warehouse as well. Let's go ahead with another one. So here the next one we have, here's your aggregates. In the aggregates here, that aggregates can also be pre-computed for loading into the warehouse, and this is an alternative to loading only atomic, that's the base level data in the warehouse, and creating in the warehouse that the aggregate record based on the atomic warehouse data, and the extractions and transformations subsystem that create a load image, that is the table and the field that is populated with the data and that are to be loaded into the warehouse, and where that the load image, if I'm talking about, the load image are typically stored in the tables that have the same schemas as the warehouse itself. By doing so, the extractions and transformations subsystem greatly simplifies the load process as well. Let's go ahead to we have find out extraction and transformation subsystem, that is extraction and transformation subsystem, that what we have to gone through with the table with the diagram here. and this is your source, which is the system tables or copies. This is the extraction and transformation subsystem, and where it is a fact. This is with the dim1, dim2, dim3, dim4. This is the load image. Here in the load image, that is dim1. This is dim2, dim3, and dim4. The extraction and transformation subsystems are here has been given. Let's go ahead to discuss about the next and the last heading, that what we have to discuss here, that gives some approaches for improving the overall data quality of an interfaces. Those will go ahead with approaches for, that is improving approaches for improving the overall data quality of enterprise. The approaches for improving the overall data quality of enterprises are: the first we have, that is assess current level of data quality. In this, that determines the current data quality level of each of the warehouse source system. And while the enterprises may have the data quality initiated that is independent of the warehousing project, and it is best to focus the data quality efforts on the warehouse source subsystem, and these systems obviously contain the data that are of interest to enterprises decision makers as well. The second we have your identify key data items. Identify key data items as well. So here in this, if I'm talking about that, the set of the priorities of the data that quality that team by identifying the key data items in each in the warehouse source system. The key data items, that key definitions, and the data items that must achieve or maintain a high level of the data quality by prioritizing the items in the manner, and the team that can target its effort that on more critical data areas, and therefore that provides a greater value to the enterprises as well. The next we have here define cleansing tactics for key data items. Here that for each key data item with a poor data quality, that define an approach and tactic for cleansing or raising the quality of that data items, and whenever possible the cleansing approach should target the source system first, so that the error are correlated at a source and not propagated to the other system as well. The next we'll go ahead with define error prevention tactics for the key data items. Define error prevention tactics for key data items. So here that the enterprises should not shop at error correction activities. The best way to eliminate data error is to prevent them from happening in the first place, and if the error producing operational process are not corrected, and they will continue to populate enterprises database with that erroneous data. The operational and the data entry staff must be made aware of the cost of poor data quality. That reward mechanism within the organization that may be modified to create a working environment that focuses on preventing the data errors at the source as well. The next we have is implement quality improvement and error prevention process. Here in this, that obtain the source and tools to execute the quality improvement and error prevention processes, and after some time the another assessment that may be conducted and a new set of key data items may be targeted for a quality improvement as well. So first of all, will be the end of this data warehouse and process and technology. We will end up here, and after that we'll start with continuing with the next more classes of unit 2 that we have to cover up in the reference towards the data warehouse and the data mining, that data warehouse that is process and technology. We'll continue in that. And first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button, and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. If I'm talking about in the terms of data warehouse here, so what we had covered up is that unit 1 which we had covered up. In the data warehousing, that we had covered up the overview, definitions, data warehouse components, building a data warehouse that is your warehouse database, mapping the data warehouse to the multiprocessor architecture, difference between the data system, a database system and a data warehouse, and multi-dimensional data model and data cubes, stars, snowflakes, star constellation, concept hierarchy, process architecture, three-tier architecture and data mining as well. In unit 2, that is data warehouse process and technology, where we have to cover up the warehousing strategies, warehouse management and support processes, warehouse planning and implementation, hardware and operating systems of the data warehousing, client server computing model and data warehousing, parallel processes and cluster system, distributed BMS implementation, warehousing software, warehousing schemas design, data extraction, cleanup and transformation tools, warehouse metadata as well. In unit 3, we have to cover up with data mining and reduction, where overview, motivation, definitions and functionalities, data processing, forms of data pre-processing, the data cleaning and that missing values, noisy data, binding, clustering and regressions, computers and human intersection, in custom data and data integrations and transformation, data reduction, data cube aggregation, dimensional reduction, data compression, numerically that is numericity reductions and discriminations and concept hierarchy generation and decision tree as well. In unit 4, that is your classification and clustering, we have to cover up the classification, definition, data generalization, analytical characterization, analysis of attribute relevance, mining, class comparison, statistical measure in the large database, statistical board algorithm and based algorithm, and that is distance based algorithm, the decision tree based algorithm, clustering introduction, similarities and the distance measures, hierarchical and a partition algorithm, hierarchical clustering, cure and chameleon, and density based method, DV scan, optics, grid based method, string click and model based method, statistical approach, association rule, and introduction, large item set, basic algorithm, parallel and distributed algorithm, neural network approaches as well. In unit 5, we have to cover up with the data visualization, which is aggregation, historical information, query facility, OLAP function and tools, OLAP servers, ROLAP, MOLAP, OLAP and data mining, interfaces, security, backup and recovery, tuning data warehouse, testing data warehouse, warehousing application and recent trends, types of warehousing application, web mining, spatial mining and temporal mining as well. And then after that we'll start discussing about the short answer question as well. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Please like, share and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you, thanks for subscribing us, thanks for viewing us.